Review. Now I can start the stream. Okay. Hi everyone. I think did that do it?
It's loading now.
Okay. Thank you for joining me. I'm sorry about those technical difficulties we just experienced, but part of the learning process. Remember, exercise your inner maker. So today I'm going to be making a live stream about the shaper making its own work table. Shaper will be planing its own work table. I've got it rigged up here, a little bit Izzy Swan style. We've got the cordless drill that's going to be driving it. But before we get into that, I wanted to kind of recap a little bit from last week. My gracious wife has agreed to help me process comments. Thank you, Kim, for joining us today. That should help it be a little bit more polished, perhaps, than last time. And before I get into that, I also wanted to go over to the table saw and talk about my plan for Lost PLA. I was out at the property last time and it didn't go so well, so I wanted to kind of do a post-mortem of that and talk about some of the materials I've acquired to try to refine my technique and make Lost PLA a reality here on Makercise. And then we'll get back over here to the shaper. So, after enough bearing with me, I'm going to ask you to bear with me one more time. Okay, so now that I'm over here at the, what is this, a table saw outfeed table, I wanted to talk about what actually went wrong. So this is the Lost PLA mold that I used last time, and I could tell that it was all cracked up. I could see down into the kiln, and I could tell there were these giant cracks. That didn't seem like a very prudent thing. Someone suggested in the comments to try and surround it with sand. I think that probably would have worked, but in the heat of the moment, in the fog of war, if you will, I didn't come up with that idea, and I wasn't able to quite follow all the comments. So post-mortem, you know, the mold did crack. It actually had, I think, fairly high levels of detail down in the mold. Hopefully I won't spill this in my keyboard, but you can make out the text on the inside of the bell that I was going to cast. So it had a pour cup, and it did burn out. It was a gray PLA that I used to print this pattern that I then burned out of this plaster mold. The plaster did not hold up, but the detail was nice. So I think if that had have held up, the pour would have turned out successful. So what I've done is I actually got some proper investment for one thing. Now I ordered this stuff from Rio Grande, but I haven't tried it out yet, so I don't want to like endorse that or anything yet, but I'm going to give it a go and see how it turns out. I also picked up a couple different sizes. These are 14 gauge stainless steel flasks, so hopefully I'll drop these down, and the shell here will keep the refractory mold kind of from cracking like this one did last week. Let's see.
Abraham's saying, he says, I'm guessing the plaster is shrunk.
You know, I left it in there for a really, really long time. Obviously, it's due to some type of differential movement in the plaster because it was solid for several days before I put it into the kiln. I left it under heat for approximately 17 hours, so I've got internet over there at the property, and I'm able to SSH into the Raspberry Pi that's on the kiln. I can check the temperature from my house, and I've got a little scheduler, so it ramped up for about 3 hours to 350 or so. I don't think I've published any of that, but when I get Lost PLA working, I will put in those details about the ramp, the types of refractory that I'm using. But yeah, I think you're probably right. It's doing some type of movement that the plaster is not designed to handle. So this stuff has, I guess I'll have to look on the data sheet has it listed, the label here on the bag does not, but it does list out some other things in addition to, I think plaster of Paris is one of the ingredients in this refractory.
Spud Forever is asking, sure it wasn't a micro air bubble?
Could be, could be. I didn't do anything to degas the plaster before I fired it, so if I put it under a vacuum, perhaps I would have removed some of the bubbles, but yeah, I don't know. I'm not going with plaster of Paris again, at least initially. Maybe once I've had some success, I might come back and try to figure out how to make a better refractory without specialized material. This is about 10 pounds. I feel like it's about $20 for the bag, and I feel like it's probably $10 or so for shipping. So depending on how much I run through, the plaster of Paris I feel like you can get more like 20 pounds for that same amount. And maybe mixing in sand. Somebody suggested mixing in sand would be a good way to kind of tackle that. But it'd be nice to be able to make these kind of parts cast after they've been modeled. I model it in Fusion 360, and then I print it using either PLA. These are ABS actually. When we get over there to the shaper, I'll show you this is actually the automatic feed drive crank, part of that, and I directly 3D printed it because it's not a high stress part in the shaper, so that's why I felt like I could get away with that. But ultimately I want to be casting these parts after designing them and 3D printing them. So
Raphael has a comment. Did you know that you can use the shaper reciprocating motion to scratch your back? Question mark. Followed by, about the cracking, put carbon powder into it like graphite.
I had somebody suggest that. I think Ben suggested it. Was that Ben, perchance?
This was Raphael.
Okay, this is Raphael. Yeah, the graphite powder, especially when I get up to doing cast iron, I think graphite's going to become an important part of the process. I'm going to go ahead and relocate back over to the shaper. Kim, if you want to be taking questions, that's fine, but I'm going to move you guys.
We've got some visitors from Italy watching today.
Hi, from Italy.
Oh, they're asking me to get closer to the mic.
Oh, yeah.
I can just try to project a little bit better.
Yeah. Okay. Okay. So I want to kind of walk you through some of the stuff you haven't seen yet. And one of the things that, I don't have all this video edited. I just was so excited to actually show you guys this machine actually doing its job and removing material off a planar surface that I had to jump straight to the live video. I've got the video for the lead screws, the horizontal and vertical lead screws. It's already available. If you go to makercise.com/signup, you can sign up for early access. That video has been out since last Tuesday, and I'll probably do either the automatic feed or possibly the work table in this Tuesday's release. But if you want early access to those videos, go to makercise.com/signup, and I am going to talk a little bit about the automatic feed. So, like I said, I've got the automatic feed mechanism installed. I'm going to be doing it Izzy Swan style with the drill driving this machine. This is a 3D printed part out of ABS. I initially printed a smaller diameter, but it wasn't getting the full range of travel, so I just scaled it up, and it's parametric design, so really fairly limited rework to print it. I think the print probably took 3 or 4 hours because it's a fairly large part. I've got a bearing down in here that attaches the drive link to the, what is this called? The auto feed pawl. Auto feed pawl is this part, and the auto feed drive plate, the auto feed drive wheel, and then the wheel is on a 3D printed, sorry for the camera moving around, but 3D printed hub. Wheel is bolted on. I cut all these aluminum parts, these 3 aluminum parts using the X-Carve, so that'll be kind of coming up. It's the first time I've cut aluminum on the X-Carve.
Do you want to answer some questions?
Yeah, I'll go ahead and answer some questions.
I think somebody's answering the question about why would you use graphite. They just were curious. And then someone was asking, I know it's very different from the techniques that you have been using, but have you considered using ceramic shell to cast metals?
So I guess, if I understand the process correctly, ceramic shell is where you put a refractory on the outside of a mold and you do a burnout, but you're left with just a shell versus like a complete cast plaster mold. I've heard the term, but I also found it a little bit difficult to get information from the manufacturers. I called Ransom and Randolph. They're one of the, major suppliers in the U.S. of investment refractory, and I didn't get my calls returned, but it doesn't cost that much to grab a 10-pound bag, and so I'll just play around with it. But if there's resources like that you feel like, you really, if this is the kind of thing you do all the time, please, hit me up on email or in the comments here on this video. I do read them all. Let me know if there's a good resource that you feel like is the right way to go. Ceramic shell, I haven't, dug into it deep enough to understand the difference between ceramic shell and what I'm trying with the refractory investment where it's in a stainless steel flask. So that's my intention, is to do the stainless steel flask, do the burnout, take the flask out, have it at an elevated temperature, and so the mold is hot when I pour the aluminum or bronze. Really, one of the things I want to do is make bronze bearings for the lathe. I need to redo the bearings in the headstock, and part of that is I want to kind of minimize the amount of machining that I have to do on it by casting them mostly in the correct shape. Flange bearing is what I'm intending on casting. Anything else? No?
I think you pretty much...
Okay, so I am going to...
Somebody mentioned they think that David Gendry has a book on making crucibles.
Possibly. That would be pretty cool to make a crucible. Okay. So this is the drive link. The auto feed Paul allows you to switch from left to right motion of the table, left to right motion, and then back again to right to left. So you can change the direction by flipping the automatic drive feed Paul back and forth. You can adjust the length of stroke, and I've modified it a little bit from the design in the book to use these 3D printed parts. But you can adjust the length, the number of teeth that the automatic feed travels by changing, where on this drive. What is it called? Drive. Whatever this part is called. Drawing a blank right now, but you can change essentially how many teeth it goes, and therefore how far the table moves. If you look at the tool here, let's see if it'll focus. All right. Yeah, it seems like it's under some tension here. Yeah. So essentially, this. The motion in the clapper block allows the tool to focus, to hinge out of the way on the backstroke, and then as it's coming forward, it digs in and it makes these chips. One of the things that I've noticed as I've kind of been playing around with it is it tends to kind of grab and then like pop out. So you end up with kind of it catching, and one of the things that I found that seems to really help is putting a little bit of weight out here on the front, and that kind of keeps it from popping up quite as seriously. I don't know, the weight just kind of seems to keep the bit from popping out, but I don't know. If anybody has any questions, go ahead and get them in, because I think I'm fixing to get this thing going.
This may be part of a conversation and I'm not following it, but where does the meat go?
The meat maybe the meat bolts to the table. So if you're going to be planing a flat surface, you would bolt that workpiece to the work table. You can see I've got a considerable amount of travel here. So something like I'm just going to grab a 1-2-3 block for illustrative purposes. If you were making a 1-2-3 block, you would bolt this to the table either in a vise or directly using some of the mounting holes that are on the table or T-track or something like that. You lower this cross-slide support and then you could take material off of this workpiece. So the meat goes on top of the work table, I guess, if that's unless it's something
Spud
else.
Forever says your angle on your cutter is a tad off than Cressel.
Possibly. So I think maybe what he's referring to, let me find a
Adjusting the tool geometry will probably help with it.
Yeah, and that's one of the things I really like these insert tools. So this might be a good. Let me see if I can get this.
From the intro picture, it looked like the ways are a little loose, or at least something is loose.
That could be one of the areas I think is maybe I'm really confident about this particular between the cross slide and the cross slide support. That is as good as I can get it. The place that I feel like might be a room for improvement, one of the first sliding ways that I did on the shaper was this ram slide, and I think probably that's where I'm going to try first, but this little weight here on the end gets it close enough. And keep in mind, the purpose of the shaper is to help get the part close, the intention being that you then go back and do the hand scraping after the machine has taken off the bulk of the work, instead of having to rely on the belt sander right there, to take down the inside of a surface that's going to mount with ways. You can use the shaper to clean up the vertical and horizontal surfaces, and then go back and scrape them. And I think it is getting it. Well, I'm not even going to go out on a limb and say anything. I've got some things to play around with, including, like, who mentioned it? Who mentioned the geometry of the tool?
Swedish Redneck.
Swedish Redneck suggests I should play around with some tool geometries, and I think I'll put that on my short list to see if we can get it going. All right, I'm gonna get this thing going here. Hopefully I don't knock my camera off, but. Get you over here. Take a look at the drive mechanism. Now it is just kind of temporarily here on the wooden workbench. The ultimate plan would be to have it sitting on this little back part of the lathe cart, and possibly driven to, from a pulley that's held in between centers on the lathe. So kind of using the lathe as part of the drivetrain to drive the shaper, and that way I don't have to make a whole separate drivetrain, I guess, for the shaper. So we'll see how that works out.
Spud Forever says experiment, you'll get it. Utilize broken tool bits, drill bits, etc. to make your cutters. And the Abraham says, yeah, I guess the clapper box would be more prone to being loose.
Oh, I'm going the wrong direction. You guys see how I did that? Went the wrong way. So let me just see if I should be able to it's not really focused where I want it. I want it focused right there on the end. Yeah, I don't want to hold my hand there particularly. Maybe down here is okay.
The frame looks very non-rigid.
I think what's going on is this whole table kind of shifts. So I think what you're seeing is the workbench, but we'll play with it and see if that, you know, I know it's not the junction between the cross slide, the cross slide and the cross slide support. It could be between the cross slide support and the vertical ways, and it is most definitely some movement in this wooden workbench.
Do you have any problems with the precision or repeatability of the parts?
On this machine, I have no idea. On this machine, these are the first cuts. You can see this is this is my complete experience set with this machine. This amount of planing or shaping. This is my complete experience set. So I can't say how this machine is performing. I just wanted to, I was so excited. I just wanted you guys to get to experience this with me in real time.
Austin tipped you $2.
Hey, thanks, Austin. I appreciate that. Like I said, this has been a long time coming, so I'm just content to sit here and watch it all day. But back it up. We'll get it over here from this angle. I also do have the ability to put this onto automatic feed. Let me get in front of the camera. Sorry about that. This is my automatic feed mechanism.
They ask you to focus the camera and you can.
Yeah, it's a little challenging.
What's the depth of the cut?
20 thou? Uh-oh, we've got a problem here. But the lead screw is not turning. So what's happening here is I'm not advancing. I'm sorry about the camera work here, folks. I'm not advancing the cutter. It's been stuck in about the same spot because possibly I haven't ground a flat. I should have ground a flat on this adapter piece, and that way the set screw would have something to bite on. I'm probably going to strip this out. Maybe this will be the first part that I do Lost PLA casting. I'm going to have to find a. I'm going to have to find a Allen wrench to tighten this up, and I also feel like I'm about on the verge of stripping out this ABS. So I kind of feel like that might be a pretty good spot to go ahead and
So somebody's asking, is it not cutting along the entire surface of the table?
No, I haven't adjusted. So that's a good question. There is an adjustment in here inside of the shaper where you can change how. So this in the back there is a channel on that's bolted to the bull gear, and you can change where this nut. You can change where this nut, it's actually a shoulder bolt with a nut on the back, you can change how far out that is tightened, and that will adjust the length of stroke. Now, I am only going back to about here, and that's just because I wanted to see it making chips. And so now that it's making chips, I can play around with the stroke length. I can play around with things like mounting it to a rigid surface. But
Raphael's cheering you on to make the chips fly. Okay, woohoo. This is Killian. Have you looked into Rick Sparber's work on the Gendry Shaper? Lots of helpful info and analysis.
Yeah, so Rick Sparber's Shaper, in fact, one of the very first videos in the Shaper series, maybe like number 2 in the Shaper series, I actually used some of Rick's footage, and you know, his Shaper, I think it does have some departures from the book, and so, like for instance, this vertical or side columns, I think he's using like you know, dimensional stock, like maybe 1/2-inch plate or something, maybe welded. I'm pretty sure he has a welded dimensional stock work table as opposed to a cast work table. And you guys haven't seen me cast this, but it was cast using Lost foam. And I actually, one of the things I'm trying to do is use, for big parts like especially the column sides, those do not make sense to 3D print and do Lost PLA. They're just too large of a part. But I think what really does make sense is to use something like a CNC router to take that material. And so I did try that for the work table, and happy with the results. But yeah, so back to the question. Rick Sparber's Shaper, I have seen. He's got a ton of papers available, and things with performance, like cut performance, minimizing chatter. Yes, I'm familiar with Rick, and I probably need to go back and revisit some of his stuff, but definitely a lot of good stuff there that Rick's put out. I think I'm going to go ahead and wrap it up.
You have some more questions.
I have more questions? All right, well, let me answer the question.
Okay, so...
if this wasn't so noisy, I'd just let it run. It's kind of noisy.
They're asking slow the feed and depth of cut.
Yes. Okay, here's what slow looks like. Oh wait, I forgot. It's not feeding, right? I've got to tighten that up. I've got work here. There's a lot of work here to get this thing to where I think it's doing its job.
I've been translating some of the comments. So Dalla says you're a genius.
Well, thank you.
Austin wants to know, is wood filament stronger than the ABS that you printed the parts in?
Wood filament? I'm not. I haven't tried any of the special filaments. They've got all kind of stuff, things that will rust to give you a little patina from the 3D print. Wood impregnated filaments. I'm not sure that the wood filament would do much better. Now, probably a fiberglass impregnated or carbon, if they have carbon, I don't even know. Probably a filament like that would do better, but I consider myself a 3D printing novice. I'm just kind of getting familiar with it and getting my hands dirty. So,
Spud Forever says, good job, Cressel. It is working now. You will learn more to fine-tune it the more you use it. Put some LEDs on that thing. And Trucking Gator says, try a C-clamp to control the speed.
Yes. That sounds like a good idea. Let's try the C-clamp.
There's no way to edit that out.
No way to edit it. This is live. This is not even a big enough C-clamp. I'm in trouble here. This is not the right size C-clamp. Yeah, that's going to be a problem. Larger C-clamp. How many more questions do we got there, Kim?
No, people are just commenting and interacting. That's all.
Okay, well, if you're enjoying it, keep interacting, and if you have ideas, shoot them to Kim. Who was that? Something Gator?
Trucking Gator.
Trucking Gator. But I do still have to. I have to get a seat. I have to get a. Allen wrench here.
Sebastian Schneider. Good job. Can you do a comparison between cast aluminum and extruded aluminum? Spud says no table drive. Don't strip it out.
No table drive?
No table drive. Don't strip it out. That's what it says.
I don't know. I got a lot of people here wanting to see some shaper cutting. I don't know. I mean, that's definitely the prudent thing to do, is to not strip this screw out.
Okay.
But
So Sebastian, sorry, I'm jumping around. Cast aluminum and extruded aluminum. Did you answer that question? I'm not.
cast aluminum and extruded aluminum.
What's the comparison?
I mean, I don't know. Probably cast aluminum is weaker, I would say. Just totally wildly guessing. I would say cast aluminum is weaker because I'm probably a little less capable of controlling the alloy compared to like a foundry that would be producing. Okay, we're back to the lead screw is moving. So I would say, I don't know if you can hear me all right, but what I would say is that cast aluminum, due to my inability to as accurately control the alloys, I think it's going to be weaker than like a cast or extruded or processed cold rolled aluminum sheet stock. I don't know. We gotta do a test at some point.
Would you recommend doing the extensive precision work on the cross slide on the shaper for the lathe? Want to build one soon and not sure if it's worth the effort in terms of precision/surface finish. Would you recommend doing the extensive precision work on the cross slide on the shaper for the lathe?
Just kind of one of the intentions I have is to go back once I get cast iron going. This is just an idea, so this isn't like a commitment. I'm not formally committing to do this at this point. But one of the things I think I might do is cast some parts for an improved carriage for the shaper out of cast iron and use the shaper to, I guess, help me machine those down before I scrape them. So we'll see. I mean, you don't have a shaper, I imagine, at your disposal if you're starting the Gingrich series. So, yeah.
Swedish redneck gave you a $20 tip.
$20. Okay. If that happens in the future, I'm gonna have a scene. It's not gonna say. It's gonna be something like this, except for it's gonna say, "You are the man." You know.
Will the ram retract enough to plane the back of the table?
It will. So one of the things that I'll have to do. It's a little hard to see here, but it's getting a little close here to the back of the. It's getting a little close to the back of the. What is this? The protractor. So I will have to modify the side of the protractor to get it to go all the way back. But there is sufficient travel in the design of the shaper to allow the ram to completely plane this entire table.
One thing not in gingery but worth trying is adding a vertical brace to the table for stability.
Vertical brace. So I presume what that means is mount this to a surface and then support it from like out in front. I guess whoever made that comment, if you could confirm. One of the things that I think would be an issue is we just lost power. My C-clamp fell off. One of the things you can tell here is that I'm kind of over to the edge, but during the whole time, this table is working its way across. And if you had a vertical support, how would you ensure that the vertical support could move? I mean, I don't have any problems with that idea, other than how do you maintain the support as the work table is moving?
Trucking Gator's asking why a carbide tip. High-speed steel would probably give a keener cut.
This is a high-speed steel insert, and I can show you what I'm using. Full disclosure, they sent me these things, so this is what I'm using. It's high-speed steel insert tooling, so you can change. You can just like carbide tip insert tooling. You can rotate that triangular cutter and get a fresh edge. This comes with a handful of bits. I think one of the other one's in the lathe, but I've also got a cutoff tool. I haven't had as much success with the cutoff tool as I have with this triangular insert tooling, but it's high-speed steel. So high-speed steel does great for low speed cutting, especially on aluminum and less rigid machines.
Somebody's asking if you have some trouble with trapped bubbles, problems with trapped bubbles.
In my castings, I presume.
Yeah.
I used to. I can show you a real good example of, let's see, where could I show you some real good examples?
When somebody's commenting, and carbide won't last long in a shaper with the interrupted cut versus HSS.
Yeah, I think carbide likes a consistent cut. So there you can see some porosity in this piece of aluminum, but when my argon tank isn't sitting over there on the welder, when I remember to take it over to the property, or come on, focus. When that argon tank isn't sitting on the welder, and I remember to take it over to the property, I bubble it through the aluminum, and that's supposed to relieve or reduce a lot of the dissolved hydrogen. But I have to use a flux to get rid of some of the aluminum oxide inclusions and I guess other debris that some of the other debris that gets into the cast aluminum. Man, it just refuses. Well, maybe we'll get a DSLR camera or something that I can actually control the focus in the future, but there it is. I'm like super happy. It's a year and a half coming. A lot of stuff moving twice that got in the way, but man, feels good to have it. Feels good to have it making chips.
You translated something wrong.
Okay.
Some joking going on.
Some joking.
Yeah.
Uh-oh.
And then I'm having to translate. No, there's just a conversation
Oh.
going. Is milling coming next? The milling machine.
Oh, that's a good question. So I have that as a Patreon goal. It's set there in Patreon. Probably I'm going to work on cast iron first. I want to do cast iron, and I want to. I got to finish this machine. This machine for one thing. It is making chips, but like you can tell, the cut quality, tool geometry, parts that should possibly be cast. There's a lot of stuff that I have on my to-do list prior to the mill. I guess I have the intention of eventually completing it, but that's kind of where it's at.
Chirpy's Tinkerings is talking. I guess he's done the gingery project.
Cool.
If you want to be true to the shaper, then you need to go out and forge out a tool bit for it. LOL.
How do you? I'm all ears. I would love to know how to forge or make a high-speed steel alloy. That's like, that's like legit at that point. I think steel. That would be really awesome to be able to, have a little laboratory foundry type setup where you could, actually do some precision alloying and even like a spectrometer to know, and maybe a little microscope to know exactly how the grain structure of the alloy, actually be able to examine that, make some predictions as to how that particular casting or billet or whatever is going to perform, the characteristics based on the alloy analysis or grain analysis. Those are anyway. I should go out and forge tool steel. I should. It's good.
What cameras do you make when you make your videos?
So this one right here is my 90% of the video I shoot comes off of this. Oh, here, this would be better. This is a Canon EOS Rebel T5i. I've had it. I started shooting video using my iPhone 6 Plus back in the day, and then I got this pretty shortly thereafter, and then I got a T6i, which I use occasionally, and then I've got a Sony something. It does higher speed, so 60 frames per second at full frame rate, and it'll do up to 1,000 frames per second at a reduced resolution. So those are the cameras that I have in my box of tools. Yeah.
Trucking Gator says lower the cross slide and you'll be able to add a vertical adjustment to the table. And then somebody else said a vertical brace fixed to underside of TS. Via a double mounting plate. I don't know, there's like multiple.
Okay.
I'm trying to
So
track it.
I think what that means is another, more distance here, right? Like a bigger triangle. A bigger triangle. Right now, the triangle is approximately, by the time you get out here to the end of the work surface, that's a pretty good moment. You've really only got support from the bottom of the cross slide up to about here, and that's a pretty decent moment. If you had double cross slides, which just in terms of the amount of work, this assembly took me about a month. So for an extra month worth of work, I could have 2 cross slides and a longer work table, more support, I guess. Let me know if that's kind of what you're envisioning. But to me, the point of making the shaper is having the experience of doing this machining project, things like the cross slide, where I really move the bar up in terms of my understanding of how to make parts mate well together in a machine tool like this. This machine tool and the lathe are not going to be like the ultimate machine tools for Makercise. At least that's my current intention. Like, eventually I want to build better machines or acquire better machines or something, so that way I imagine at some point I will get good enough as a machinist to be limited by these machines. I'm not at that point right now. Right now these machines are every bit as good as my understanding. So it's not to say that these are great machines. It's to say that my understanding is at a novice enough level that I have a lot to learn using these machines. And when I'm, done learning from them, I hope to have, either build better machines or buy better machines to help me do cool projects. I ultimately want to build cool things with machine tools as opposed to building cool machines with machine tools. I like building machines, but I also want to build cool things.
Chirpy's saying try some pool shop granules, calcium chloride, the porosity that works best for degassing for the home shop guy.
I've tried a number of different granular additions to the molten aluminum for the purpose of degassing, and I guess they seem to work okay, but I think in industry they use either nitrogen or argon, and so that's why I went with the argon. I think in an industrial setting, that's what they're people are going to use. So for me, I guess the concern is if I had to go out and buy another tank so I don't have to transport this one back and forth, it's $250 US for the tank plus the gas. So I guess that's the concern. Whereas some pool chemicals or light table salt, these types of things are a little lower initial cost, but in terms of the bang for the buck, I think going with something like industry is using makes the most sense, because it's kind of been proven as quite likely the absolute best quality outcome, the most controllable outcomes, which is why they use it in industry. So that's the approach I've been taking. I don't want to say I won't ever try anything, but I've tried enough that I feel like I like the argon. So I don't know. If I have to fill the tank a couple times, and I might get a little light in the wallet, I might not want to do that, but we'll see.
So why make machines out of cast aluminum? Why not use mild steel and a welder?
I guess because it's so cool to be able to cast metal. Realistically, I think you probably, performance-wise, would be better off with some type of machined, or not machined, but mild steel constructed machine. I mean, this has cold rolled steel in it, so at least the ways are made of steel in this machine. I think the ability to cast is really something that I really think it's right up there with other things that I think home shop should have. I don't do a ton of woodworking, but if really, I think it's the kind of thing that's right up there with 3D printing or having any kind of automation in your shop. Having the ability to take a pattern and reproduce it in aluminum, bronze, or even cast iron, I think that's a really powerful tool for a hobbyist, and that's why I felt like going down this Gingrey lathe series or machine tool series was something I wanted to do. And in terms of the aluminum, yes, it would be better to have cast iron. A welded steel machine is probably going to perform better than cast aluminum, but I think casting aluminum, being able to scrape more quickly, get to a point where you can actually see a machine tool making chips, I think there's a lot of benefit just in terms of your own inertia to be able to see a project to completion using aluminum. I don't think it's going to be the ultimate tool that you're going to use for, that you're going to use for 50 years and then pass on to your kids. It's a tool that is helpful for doing some machining, but mostly for helping develop your own personal machining skill set.
Once you've got the shaper done, go back and refit a servo to that cross feed.
You've read my mind. You've read my mind. Like I want
to control cross feed.
A sensor that's like an analog sensor for the ram position, and then advance it. Oh, also the down feed. Have the down feed to where it's tied in. You can have a CNC shaper. Total oxymoron. Like it's very anachronistic to have a CNC shaper. But I agree. If it wasn't just such a cool mechanism, there would have been a little stepper on that cross slide. So yes, we are along the same thought processes.
I've seen roller feet on a scraped rail for a vertical brace for the table.
Roller feet. That's plausible. It's plausible.
Trucking Gator says no. Drop the slide and add a second plate on top of the existing one, but use adjusting bolts to raise and lower the plate added to the top of the table. You don't have to. I don't know. I'm just reading.
Trucking Gator?
Yeah.
Trucking Gator. If you have a link or something that you can put in the comments or shoot to me in an email, I'm kind of having a hard time visualizing what you're describing. I'm all ears for improved rigidity for this machine. I've got to kind of weigh that with like the ultimate plans that I have for videos I want to make versus time investment. So if you've got a good resource like a link or something, I'd love to check it out. So if you can, shoot that to me either in an email, kressel@makercise.com, or down in the comments.
Sorry, there's funny things happening. Elevation could be achieved with lead screws that I read that already, and stepper motors.
Yeah, so elevation, so there's actually two different elevation adjustments on this machine, and let's see if I can get this adjusted here. No, it's not going to cooperate as much. So there's the down feed. This is the primary vertical, or you can do dovetails with it. So this is the primary adjustment for the cutter vertically. there is another lead screw here in the back. I don't know if you can quite see, but this allows you to adjust the entire work table or entire cross-slide support up and down on vertical slideways. I wouldn't imagine. I think it would be kind of unproductive to put this onto some sort of a drive, like a stepper drive. But I think the one up top here would be, that one could be cool.
There is some conversation happening about a CNC shaper. Check out hydraulic shapers with tracer attachments. They were similar to CNC shaper idea, but use hydraulics to do custom profiles and shapes on the shaper.
Yeah, I have not heard of that.
The rigidity thing can be taken care of by a depth of cut and feed. I guess you can't really do much for aluminum, but by taking light passes and nibbling the work away slowly, you can get nice flatness. That's pretty much the last comment we have right now.
Okay. Hey, I'm going to go ahead and wrap it up here. I really appreciate those of you who came out to check out this video. I'm super happy having the shaper actually making chips. And yeah, I mean, like I said, if you think you're interested in seeing these videos before they go out on the channel, check out makercise.com/signup, and I'll get you a link at least 1 week early for videos as they come out. And anything else? I think that's it. Oh, and special thanks those of you who tipped or whatever. That's such a big encouragement. I really appreciate it. I hope you guys enjoyed this live session. If you did, give me some feedback, things you liked, things you didn't like, and we'll try to have ones that I feel like are a little bit more successful this week versus the Lost PLA. Thanks, Kim. You're awesome.
We knew that was going to be rough if you didn't have help.
Yeah,
so.
help really helps.
Help helps.
All right. I hope you all have a nice rest of your weekend, and I look forward to seeing you guys again sometime soon. Cheers.